Alright, this is the second paper that you got last. Actually, I don't think I handed it out, so you'll have it now. And it is called Functions in Graphing. It's somewhat related. Before we actually get into anything, I want to tell you of one change so you don't work ahead and realize it's different than what we're doing. So if you go all the way to the very last problem, I changed this. So just in case you're confused or you get to that point and we switched it, just cross off what you have and switch it to this. It actually will fit on the graph now. The other one really wouldn't fit on the graph. Okay, going back to the beginning. So this is big on something called set builder notation, and it's not a huge part of the year, but it is something that can be confusing if you've never seen it before. And it starts with we got to start getting comfortable with all the ways math is written, and especially functions are written. Okay, so right away it says define the graph of each function in set builder notation. Now, set builder notation, we're going to do a little aside here and say what set builder notation, how it's built. So we use the curly French brackets to denote a set. It ends up creating a set. And we put in parentheses basically the function. So we always say x comma f of x. In other words, we say what the domain is and we say how you get the range. That's basically it. That's just a regular old equation. We say we say the things we're going to put into the equation, and then we say the equation. And then you put, it's kind of like an absolute value bar. If you were looking at a keyboard, this is the one that's under backspace. It kind of has the straight line and then the backslash or forward slash, whatever that is. And then you say what kinds of x's you can use. So for this little template, we're going to say what type of x are we using? And then you do a comma, and then you write here your domain, squeezing it in here, restrictions. Oh, this is terrible. And then you finish your curly brackets. And you'll see when we get to an example what this means. Sometimes there are no domain restrictions. Alright, so here's this normal equation. F of x, or remember, y, equals 2x minus 4 over the set of real numbers. So we'll start with our curly French brackets. We say parenthesis, x, we're plugging in, into 2x minus 4. So over there when we said f of x, we actually write what f of x is. Notice f of x equals 2x minus 4. And then we put our bar. And when you read this in set builder notation, that is read as x gets mapped to 2x minus 4 such that, so you say either such that or where when you see that bar. Where is sometimes nicer. Where x is a real number, and you just have to say x space real. Sometimes people say x is an element of the real set. That is like a weird E. It's like a sideways U with a line through it. That's some set notation there, but you don't have to use that symbol. And then comma, and this is where the domain restriction is, but they don't give us a domain restriction here. So we can just end it like that. That's all they want you to do in this first part. In B, I got rid of this extra weird negative that's on your paper, so sorry about that. It's just supposed to be one negative. So again, we write parenthesis x comma negative 1/3 x, parenthesis where x again is real, so real number, and then comma, this time it says from -3 to 2 inclusive. So we have to write this in a more technical way. We'd say from -3, so x is greater than or equal to -3, and I knew it was or equal to because it's inclusive. And x is greater than or equal to 2. So x is somewhere in between -3 and 2. So if we were to graph this, we'd only graph from -3 to 2 as far as the x values go. Alright, let's move this up a little bit. Again, we want to start the same way, x comma 2x squared plus 1. You can see this is not super exciting after you know what to do. Such that, or where x is an integer this time. So if you were to graph this, you actually couldn't connect the dots. That's a weird thing. You couldn't connect the dots because in between those 1s, 2s, and 3s are decimals and they're not integers. Comma says from 1 to 5 exclusive, so we do not include. So we're going to use less than and greater than symbols. So 1 is less than x, which is less than 5. And I just realized I did a goofy thing up here. I wonder if anyone caught it in class. That should have been the same way. Whoop. Put my eraser on the marker spot. So I didn't mean to do that. It meant x has to be less than 2. So if you caught that, nice work. I owe you a piece of gum. And in D, again, this one doesn't have domain restriction, so it's shorter again, where x is real, and that's it. There's no restriction, so you graph everywhere. You put arrows on your line, or on your, this is actually a cubic. Alright, and number 2, given each graph in set builder notation, produce an appropriate sketch on the axis provided. So this time they give you the function in set builder notation, and we have to graph it. And this is where our calculator is going to help us big time, especially with the domain restriction, because we'll need to know where to stop and end. Stop and end? That's the same thing. We'll need to know where to start and stop. Alright, so our function is this, f of x equals 2x minus 1. But we can only go from -3 to 2, and we have to somehow show on the graph that we're not including -3, nor are we including 2. Okay, so let's get this calculator doohickey back out. It's going to have the same stuff that we left with. I'm going to clear these equations out. I'm going to write 2x minus 1. Again, this is not a hard one to graph. Probably could have done this just as easily without this. Move this down a little bit. And we're going to go to the table. Again, you can see how even though it's a graphing calculator, it's really the table that is much more useful to us. Okay, so we had a domain restriction of -3 to 2. If you look right here, I'm not in the negatives enough, so I'm going to go up. I only want to go from here to here. So I want this little block right here. Ooh, I can do a cool thing, I just remembered. You're going to be impressed with me after this. I have a little snapshot tool. New snapshot. Alright, and I'm going to get rid of this window. And I'm going to paste it. There we go. Delete, delete. Move it up. Okay. So now I have my table and I can plot these points. And I'm just going to plot both of these onto the same grid. -3, -7. Alright, I'm going to pause this, graph it, start it again. You can do the same thing. Alright, so here are all those dots. Now, the problem is we don't want to actually include -3 and 2. So we can't really put them as dots because they look like all the rest of the things I'm including. So instead, when you don't want to include something on a graph, you leave it an open circle like that. So we're going to do that to either end. You're using pencils, right? And then we can connect. So you kind of leave the ring that you made, the little circle, open. So don't put your line through it. And there you go. That is the function f of x equals 2x minus 1 from negative 3 to 2 exclusive. Lots of big words there. Alright, we're going to do the exact same thing for, why does it say part A again? That's weird. I think that switched when I pasted. Oh no, it says A on the paper. Okay, well, it's part A twice. Alright, we're going to do this little function that we're going to see a lot more of next unit. This is called a quadratic. It'll end up looking like a parabola, but it'll only look like part of a parabola. Alright, I'm going to get our calculator back up. We're going to clear our y equals out. And we're going to enter this new one in. It is x squared minus 2x plus 1. Alright, and again, you can look at the graph if you want. I'm not sure where my window was. Probably in a bad spot. It's not even showing it. Zoom, fit, which is I think 0. Did it do anything? Apparently didn't do anything. Yeah, I thought I hit the right button there. Zoom fit, and then you can see what the parabola actually should look like if you graph the whole thing. Well, we're not graphing that whole thing, so we're going to go to the table. And we want to go from negative 2 to 2, and this time we are including all that. I'm going to get my fancy snippet tool out. I'm going to make a new snip. And I'm going to go back to this. And we're going to paste it here. It probably won't even fit. Yeah, let me just make it a little smaller. Actually, I'll change this. Oh no. I went far away. Is this the most exciting video, watching someone figure out how to use Microsoft Word? Okay, there we go. Now I'm going to graph this. I'm going to change my color though, so it's not confusing. Purple. And we want to graph these numbers. Negative 2, 9. All the way up to 9. This time I don't need to worry about open loops because we're including everything. 0, 1. 1, 0. And then back up again a little bit. So that's something called the turning point. That's where the parabola turns. And you kind of have to use a nice smooth pencil and curve it as best you can. They are not connected with straight lines. So this should be B. So we'll label that B. This was A. And there you go. Alright, remember, pause if you need a breather. I kind of go from one problem to the next without much of a break. So please just pause it and make sure everyone's caught up. Number 3, write the domain and range of each function below over the given interval. So again, they give us the function. There's no set builder notation in this right now. But they give us a a domain restriction. We can only go from negative 4 to 2 with the x values. So they actually give us the domain. So when it says write the domain and range, we have one of them. We know that the domain is negative 4 to 2, and we write it just like that. What we don't know is the range yet, and we have to actually plug in the domain in order to find what the range is. I can tell this is a linear function because of there's no exponents, there's no weirdness. It's a slope and a y-intercept. So I could probably do this by hand pretty easily, but again, we might as well use our calculator. So I want to bring up the calculator once again. And I'll clear my y once again. And I'm going to enter 1/2 x. So you can either write just 0.5x or 1/2 x minus 4. And I want to go to the table. And I wanted to go from negative 4 to 2, so my window's pretty good right here. So it looks like when I go from -4 all the way down to 2, my y values go from -6 to -3. And they just kind of increase from there. So that's what I want to say for my range. And, oh, I dropped the wrong thing out of the window. Here we go. So my range will be from -6, and remember, don't write x, to -3. We want to write the notation they use, so f of x. Yes, if you wrote y, I wouldn't take off points, and it does show me that you know that that means the same thing as y, but we want to stick with what they have. Alright, and then in B, we want to do the exact same thing using the using the graph again. So this time it's x to the 3rd power. I'm going to clear it. We say x to the 3rd. We're going to use the table again. And I forget what the domain restriction from -3 to 1. So again, we don't need to change anything. I want to get rid of this because that was the old one. We want to go from -3 to 1. So we're going from -27 to 1 for the y values. Alright, so this is, cancel that. Again, the domain, that's easy. The domain is -3 to 1. The range was what we just circled. Was it 26 or 1? I meant 26 or 27. It is, oh yeah, it's 27. That makes sense because 3 cubed is 27. And again, f of x to 1. So that's what that means. It means when the domain goes from -3 to 1, the range will go from -27 to 1. Alright, we're going to finish it up with number 4 here, part A and part B. It says sketch the graph of the functions defined by the following formulas and write the graph of y equals f of x in set builder notation. So good, let's just do the set builder notation first. Again, we need French curly brackets, parenthesis, x goes into 3x minus 8, where x is real. And in neither of these, they give a domain restriction, which probably should have added one in just to practice that, but that's okay. And we really don't even need the graphing calculator for this one, because I don't need to even be careful that I'm using the right x values. I can use any x value I want. This is also in slope-intercept mode or form, so I can say this is the slope, this is the y-intercept. So I start at -8 and I go up 3, right 1. So again, that's faster than using the calculator. Now I can put arrows on because it goes forever in both directions if you don't put a domain restriction on. So x, the domain in this case, would be infinite, from -infinity to +infinity, and so wouldn't the range. The range would go from -infinity to +infinity. And then the last one, which moved to my next page somehow, is another quadratic, or it's going to be a parabola. We get to draw the whole parabola this time. And again, this is the one I changed, so if you didn't change it now. And this one we will use our calculator for, to at least get the table. Now we can look exactly what it looks like in the calculator too, but it's really hard to copy a graphed parabola from the calculator to a graph on your paper. So the table is going to be better for that. Last time bringing up this calculator, we're going to get y equals, we're going to clear it. I'm going to erase my writing over here. And I'm going to enter in -x squared there we go. Is it not? There we go. -x squared plus 2x plus 5. And again, the table. And again, we don't have a restriction, but we want to pick the numbers that we can graph. So we can go from -3, -10, right here. We can do this one, all the way to 5, -10. And it kind of loops between there. So again, I'm going to cheat and use my snip tool. You guys can just have two things out at the same time, old school way. Alright. Oh, I snipped more than I needed. So at -3, I'm going to go all the way down to 10. Right there. That's that one. -2, -3. This actually goes fast. After you get kind of over the hump, you just kind of follow the same pattern going the other way. 0, 5. 1, 6. And then that's the apex, I can tell, because then it starts going back down from here. So I just kind of mirror it on this side, so I don't even have to look over there. And there it is. And you do your best, kind of, it's all in the, you don't really want to move your wrist around. Just kind of want to move your arm and glide it. Parabolas don't curl back in. There is never a straight line on any part of them. They don't have a point where they turn. There's not like a pointy part, I should say. And you get better at it as you go. Okay, so that takes care of these two papers. You can turn those papers in. You can await further instructions. But I am going to post these eventually so that, especially if you weren't here today, like I was not, you can see them on your own and follow along with them. Or you can just come back to them later when you're not understanding something about set builder or something about domain restrictions, something about something that you remember was in this video. Alright, have a wonderful rest of your day. Again, sorry I'm not there. I'll see you next time. Bye.